In this video, we'll explore practical strategies for reducing network latency in cloud environments, enhancing performance, and equipping you with skills to optimize your cloud deployments effectively. Welcome to our deep dive into network latency optimization for cloud deployments. As cloud computing becomes the backbone of modern IT infrastructure, understanding and reducing network latency is no longer optional, it's crucial. Did you know that just a 100 millisecond delay can cause a 7% decrease in conversions for a major e-commerce site? In this video, we'll walk you through practical strategies to minimize latency and boost performance in your cloud environments. Stay tuned to learn actionable insights and optimize your cloud deployments like a pro. Network latency refers to the time it takes for data to travel from source to destination. In cloud environments, latency can significantly impact performance, affecting everything from application responsiveness to user experience. Factors influencing latency include geographical distance, network congestion, and protocol overhead. It's essential to differentiate latency from bandwidth. While bandwidth is the capacity of the network, latency is the delay experienced. High latency can lead to lag and reduced satisfaction, making its optimization a priority for cloud-based applications. By understanding these basics, we lay the foundation for effective latency management.
Latency in cloud deployments can stem from various sources. Geographical distance is a major factor. Data traveling across continents can naturally introduce delays. Network congestion, where data packets compete for bandwidth, can also slow down communication. Protocol overhead, the extra data added to ensure reliable transmission, further contributes to latency. Additionally, server processing delays and data packet loss can significantly hinder performance. By identifying these common sources, we can target and mitigate them, paving the way for optimized cloud environments. Geographically distributing servers is crucial for reducing latency. By placing servers closer to end users, data can travel shorter distances, minimizing delays. This setup not only enhances performance but also improves redundancy and load balancing, crucial for maintaining service during peak times or outages. Furthermore, it supports a global user base, ensuring consistent experiences regardless of location. Strategic server placement is a foundational step in latency optimization, enabling faster, more reliable cloud services. Content delivery networks, CDNs, are powerful tools in the latency optimization arsenal. By caching content at multiple locations worldwide, CDNs ensure that users access data from the nearest point, significantly reducing latency. This setup not only improves load times but also enhances security by mitigating DDoS attacks and reducing server load. Additionally, CDNs optimize resource usage by offloading traffic from origin servers. Implementing a CDN can transform your cloud deployment's performance, offering faster, safer, and more efficient service delivery.
Edge computing brings computation closer to data sources, reducing latency by minimizing the distance data must travel. This decentralized approach is particularly beneficial for real-time applications, IoT devices, and big data analytics, where rapid data processing is essential. By handling data closer to users, edge computing enhances application responsiveness, offering a seamless experience even for bandwidth-intensive tasks. Adopting edge computing can significantly elevate the performance of your cloud deployments, catering to the increasing demand for speed and efficiency. Network protocols play a pivotal role in determining latency. Protocol overhead, the extra data added for error checking and control, can affect performance. TCP, known for reliability, can introduce more latency compared to UDP, which offers faster delivery with less error checking. HTTP/2, with multiplexing capabilities, reduces latency by allowing multiple requests on a single connection. The QUIC protocol, developed by Google, further enhances performance with reduced connection establishment times. Selecting the right protocol based on application needs is crucial for optimizing latency in cloud environments. Monitoring tools are essential for detecting and addressing latency issues in cloud deployments. These tools provide real-time visibility into network performance, enabling proactive optimization by identifying bottlenecks and anomalies. With detailed analytics, they offer insights into latency trends, helping teams make informed decisions. Many of these tools seamlessly integrate with cloud platforms, providing a holistic view of the network. By leveraging monitoring tools, organizations can ensure optimal latency levels, maintaining high performance and user satisfaction.
Exploring case studies of successful latency optimization provides valuable insights into effective strategies. By examining real-world examples, we can identify what works and the challenges that were overcome. These studies often reveal quantifiable performance improvements, offering a blueprint for similar scenarios. By learning from these examples, organizations can adopt proven techniques, avoiding pitfalls and enhancing their cloud deployments. Case studies serve as a practical guide, demonstrating the tangible benefits of targeted latency reduction efforts. As we conclude our exploration of cloud latency optimization, remember the key strategies: understanding latency sources, leveraging CDNs, implementing edge computing, and selecting appropriate network protocols. Continuous monitoring remains crucial, as technology and user demands evolve. We encourage you to apply these learnings to your deployments to enhance performance. Share your experiences and insights in the comments below, and let us know what topics you'd like us to cover next. Together, let's continue optimizing and advancing in the cloud computing realm.